Hello, this is Mark Summers from Summers Technical Services. I'm here with the senior design team from Texas State University, the RSI striping team, Steve and Sergio and Nate. And we're talking several SolidWorks topics we're going to get to. So we're going to talk about SolidWorks memory requirements and then talk about SolidWorks file management. And then if we have time, we'll get into some SolidWorks simulation. Specifically structural analysis, static structural analysis. So thanks for showing up, gentlemen. First thing with computer memory, had students ask me about SolidWorks not running on their computer, their educational version that they've downloaded. And so what you need to do is go to your settings. I'm going to right click on my PC here on the desktop and go properties. And you'll get a listing of your computer memory. And on my computer, I've got 64 gigabytes of installed RAM. And some students have as low as 8 gigabytes, even less than that sometimes. And when they complain about sluggish behavior, that's a problem. And so if you go to SolidWorks website and just do a Google search for SolidWorks requirements, and so I've got a web page here. Just Google SolidWorks requirements, and you can come down here and see, okay, for SolidWorks, new version of SolidWorks needs Windows 10, and it's telling you need at least a 3.3 gigahertz processor, need at least 16 gigabytes or more, so 8's only half as much as you need. So 16 is a minimum, what they're saying. Graphics cards, I'm guessing that most of you don't have a dedicated graphics card. A lot of these lesser expensive laptops have built-in graphics on the motherboard, and there is no dedicated graphics card, which also causes performance issues. And so you need to find out what kind of video card you have on your computer. And again, going from the display settings, or from the settings in your Windows, go to display, and then scroll down here to the bottom somewhere and look for advanced display settings. And I've got multiple monitors. I'm going to switch to my internal monitor that's got that dedicated graphics driver. And if I come down here at the bottom, it'll tell me my resolution, bit rate, where is it more information? Display adapter properties for display 1. And so this is looking into the computer and finding my dedicated graphics card, and I've got 32 megabytes, excuse me, 32,000 megabytes. That's 32 gigabytes of dedicated video memory. And that cost, the additional cost I had to pay to get that was not hundreds of dollars, but it was like $1,000 to get a dedicated card. They're probably cheaper now. But you don't have to have 32 gigabytes of video RAM, but you need to check to see what video card you do have. And then once you find that, go to this certified cards and drivers link, and you'll be able to go in here and tell it exactly what computer you have. So I'm going to say I want for version 2021, I've got a Dell, I got a Precision 7750, and I've got a Quattro, well, that's not even it. $7730 is what I have. And then graphics cards, I've got a Quattro P5200. And down here it's telling me that this is a certified card. They've certified it. And this is the driver that I need to use to make sure that it runs optimally. So you should search your computer, find out what graphics card you have, and then go look and see if it's a certified card. And if it is, then you're good. If not, then that could be another issue. So Nate, I think with your your issue, you've got 8 GB of memory, so I think that's the problem. So unfortunately, my answer is you got to either go pay more money or to get more memory, or you live with what you got. The other option we're going to do on Friday is we've got remote desktop access to one of the lab computers, 3309. And so you can log in from home, run SolidWorks on the computer in the lab from your home. All the processing, everything happens on the lab computer. The only thing it pushes to your screen is the image that you're going to see. And so if you've got a lousy internet connection, it's still going to be crappy. But if you got a good internet connection, you'll be able to feed that graphics information back and forth. So I think that's your solution, Nate, is to try that on Friday. Does that make sense, Nate?
Yes, sir.
Okay, so Sergio and Steven, do y'all have similar issues running SolidWorks at home?
Yes, last night I was like, my SolidWorks was freezing.
Okay, all right. Go through those steps I looked at and see if you even meet the minimum requirements. And if not, it's just going to get worse. It's not going to get better. It's going to get worse because your assembly is going to get more and more complicated as we go through. So look at that and be prepared to talk about that on Friday. All right, so we'll put that one to bed. Let's talk about SolidWorks file management. So when you sent me those files yesterday, we went through 2 or 3 hoops, 2 or 3 iterations. I never did get what I needed because you've got problems with your file management. And so these are the files you sent me in a couple of different, you sent me a couple of zip files. You sent me this one and then you sent me this one. And it still didn't fix it because your files are all over your computer. So when you on your computer, you've got files in multiple folders and you don't even know where they are. Maybe you do, maybe you don't. But they're not all in one location. So step one is every single file that you're using should be in the same folder. So what I think you did, you went in and grabbed up a bunch of files from a folder that you thought all the files lived in, and then you sent it to me. And then I get this, where's my window with my, where's my, yeah, here we go. I gotta find it, here we go. So these are the error messages I'm getting. So open up your top level assembly and it says, I can't find pillow block bearing block.sldprt. Well, it's in some download folder. Does this make sense, Stephen, with where this folder is pointing?
Yes.
Okay, so what's happening is you're going and you're getting files from the internet, which is a good thing, and Windows automatically places them in a folder called downloads. And so before you do anything, you need to go to your downloads folder and go find that file and then put it back where it belongs, which is in this common folder. And then place it in the assembly, and then it'll know where it's at. Does that make sense?
Yes, thank you.
Okay, and same thing down here. There's another file here. This is a copy. It's got parentheses 1. Well, this scares the hell out of me because you've got this file probably in here somewhere, and you got another copy floating around in the downloads folder. And so when you open this thing up, I don't know what it's opening because if you open up this version, it's going to open up one set of files and the other one's open. So you can't have multiple files floating around on your computer. So what you need to do is just the bottom line is put all the files in one folder. And you can't willy-nilly move them around because if you move them from the download folder into another folder, well, SolidWorks still thinks you have it in the download folder, so I don't know where it's going to go find it.
Do you have to move?
You have to.
File?
You have to. It's a pain in the butt because we should do this at the beginning so we don't have to fix it. But let me show you how to try to fix it. So if I open up your assembly, so now I'm back in SolidWorks. I'm going to say File, Open, and I want to open up. See, there's multiple copies of this thing. So I want to open up this thing, maybe. And some good stuff comes up, and then let's see what happens. Okay, so it's got some errors. So this is, I think Nate was talking about him getting errors, so he may be getting the same errors, some rebuild errors. I don't know what these are, but this has to be resolved. It looks like I don't know what's wrong with it. So we need to figure out what this is. I don't know if this has happened on your computer or not, but this is what I'm seeing when I open mine up. All right, so file management. The number one rule is keep all the files in the same folder. So to fix this problem, you can gather up all these models and do a pack and go, and it'll gather everything up. So that was what I was trying to get you to do yesterday, but I know you didn't do it because when I see the files, when you do a pack and go, all of these file dates are going to be identical. It makes new copies of everything and puts it in one nice packaged bow with a bow on top so that you know you have everything. So I want to make a quick folder here that says new folder. I want to say 2 summers. And I'm going to go back over to your thing, and it's missing. Oh, maybe all the parts are here. Does it look like all the parts are here?
Yes.
Okay, so so to do a pack and go, just open up the top level assembly. So this has an assembly. This has there's some parts. There's another assembly, and so this has sub-assemblies inside it. So this is everything, I think. And so just say file, pack and go.
Yeah.
Well, you say, yeah, but you didn't you didn't do this last time.
Oh, I did that for the second email.
No, you didn't, because I still got I didn't get the dates were all different. Maybe the second one was I quit looking finally at 8 o'clock last night. So when you do file
Yeah.
and go, I need more memory. Look at this. It's locked up here. File, pack and go. In the world. File, pack and go. It's got lots of different options, but just leave everything the same and just go browse, save to folder, go browse to a new folder. And the new folder is going to be, in my case, it's here. And this is my file management. Everything to do with Texas State University is in one folder. And once I get here, I got multiple classes. If it's related to you, I want to go to your class. And then I got a folder called projects. And then I got every single team project is on the list here. And I go to your team. And then I got a folder called Solidworks. Everything that I'm ever going to do is inside this folder based on your project with Solidworks. And so here's a new folder I just made. So I'm going to select it and say select folder. And so now I've selected that folder to put this whole gigantic thing in and make a big copy and put it all over there. So once I say save, and again, there's lots of options. You can add suffixes and prefixes to the file names, but I'll just leave it all default. And just say save, and watch what happens to this folder once I hit save. Oh, where did it go? There it is. That's everything this assembly needs. And you could just zip this up and send it to Summers and say, here's my thing. And even if you had files in downloads and on your desktop and on a thumb drive, if you had it completely screwed up on your computer, it knows where they are because that's where you put them when you put them in your assembly.
Yeah.
And it'll just gather them all up, and I won't have to complain about getting those error messages.
I guess the date didn't change though.
That didn't change. You're right. So that was a wrong statement. I thought it made new fresh dates, but it just puts the date of the last one. So that was a misspeak on my part. So so I do believe you that you did that the second time. So good.
I think there's something wrong with one of these sub-assemblies that shows that error message.
Yeah. So this one
and
didn't get this one. You're right. This one did not get these error messages. Where did it go? It didn't get these error messages because those files were sent.
Yeah.
This is just some kind of constraint thing that we can try to figure out. And so what happens is if you got an error down here, it's going to trickle up to the top. So here I've got an assembly here, and there's something wrong. There's a mate that's not right. So you can just right click on that discrepant mate and say delete. And then there's something else that's wrong. And so that fixed that red thing, but now there's something else down here. And so you just have to systematically go through and get rid of some of these constraints. Or you can edit it and try to figure out what's wrong with it. But generally I just find just delete the ones that are failing. And so those two errors, now everything is fixed.
Oh, wow.
So
Nice.
yeah, sure.
I'll have to do that on mine.
So you'll need to just go in there and delete it. Now it's under constrained because it's got the minus sign on there. So what does that mean? Well, that means that this thing is not tied down. Oh, you got it rotated. So that's okay. And so maybe that minus sign is okay because you want it to rotate.
Yeah.
But another issue I'm just now seeing, this F on here, what does that F mean?
A different file?
No, what that means is that when you place the very first thing in your assembly, you go insert component, you find it, and you click on the screen to place it. It puts it wherever you click on the screen, and it locks it down to the world and won't move. The problem is you don't know where it is. And so that first part, you need to float it and then tie it to the planes. Because right now your main assembly is in there in some weird orientation. So those are the assembly planes, and they're all out in some weird location. And so you want your assembly to be lined up with these planes. So the way to fix that is I want to do a space bar and do a ISO view. And so this is another problem. You don't want your ISO view to look like this thing has been blown over in the wind. You want it to be oriented just like it sits when you think about this thing, when you dream about it at night. So this is the orientation you want. And it's looking like that because when you place that first part, you just clicked on the screen and went. And it's crazy hard to rotate this thing because it's in this weird orientation. So let's fix that. So I'm going to spacebar ISO view. I want this thing to sit in a logical location when it's in the ISO view. So the first thing you do when you place your very first part is see that F on there and realize, oh, that thing is fixed. I'm going to right click on it and say float. So that takes away the F, and now it's not fixed. And now, unfortunately, all of these things can move willy-nilly here. And so what I need to do is orient this one to be like I want it, and the rest of them, if you constrain it correctly, they'll follow.
Okay.
Okay, so when you think about this thing, does it sit like, I can't even get it rotated around like I want. Does it look like, doesn't look like that, does it? Does it kind of look like this?
Yeah.
Does it go a long ways this way?
Yes.
Kind of, sort of. Okay, I want to orient it the way I think it should be, and then if we want to change it, we can change it. All right, I want to go back to my ISO view. Come on. Go back to my ISO view. All right, so this is the first part, and so this is the part I got to constrain to the assembly planes. And so I want to open this part up, and I'm going to find, there is the front plane of the assembly, and here's your part, and the plane I want it to line up with is, I believe it's this one. No? I want that thing to go this way. Yeah, I want that to be, I think I want it to line up with the top plane. So I'm mating the front plane of the assembly to the top plane of this guy. And when I say mate, it's going to spin it around the wrong way, and I want to flip it. And that's what I want. Okay, so that's oriented in a logical way. So I'm going to say okay. Now I'm going to do top plane to front plane, mate. And that's going the wrong way, so I want to flip it. All right, you with me? Does that look a little better? Say yes.
Sorry, yes, I was muted.
That's okay. All right, so now what can I do? Well, I can only move in one direction now, so let's fix that last one. And that means I need to mate the right plane of the assembly to the right plane of your first part there, and I'll mate that. Now that frame can't move. And it's also is oriented in a logical way to me anyway. And now this thing can rotate and the rest of it stays put. And so if you want it to rotate 90 degrees about a vertical axis to orient the other way, then you could just swap a couple of those planar mates and do that.
Okay.
Okay, so this is the way you should do every single assembly. You should do this first. So you had everything mated to the other parts good. It just that first part was not floated and mated. All right, so that takes care of that. So I want to do a save as. I want to save this as Summers Assemblies. I don't want to screw up what you gave me. All right. All right. So now we need to look at some more file management stuff. And so you've got these part numbers. This is really good. Except this one should be called TSU-064-07-101 or something. Right? This should be the one I'm looking at now. This is the 100, right?
Yes.
So this one.
Oh, so instead of.
I mean, you don't want any words in here because you're going to have other sub-assemblies. And you won't know which assembly is which.
Yeah.
So I'm going to say File, Save As, and I want to call this thing. I want to give it the real name. This needs to be 101, or maybe 100. 100 is the top one, right? So this needs to be 100. Okay, now we've got this one. This is a subassembly. This should be maybe a 101. It's like the next to the highest assembly. And you need to come up with these numbers. I'm just doing what I would do. So to change that, I can't go in here and rename that file here because then the assembly won't know where it's at. It's looking for 07-assembly. If I rename it here and then open it up later, it's gonna give me another error message. Does that make sense? So here's how to fix it. I wanna open this assembly up. I want to right click on this subassembly and open it. And once I open it, I want to save it as a different name. And when I do that, there's a couple of options. And so I'm going to say File, Save As. It's going to give me three options. The first two is what I'm really interested in. So read these and we have to understand what this is saying. The first one is what I want to do right now. Save As. Saves this document with a new file name. And this is the important part. Open files that have references to the original document will refer to the new file. Well, I've got that top level assembly open. And so if I do a save as and use that option, it's not only going to give this file a new name and put it on my hard drive, it's going to tell that assembly to now point to this new file. If I didn't have that top level assembly open, then it wouldn't even ask me this question. And then when I open the other one up, it would still point to the old file. So when you do this, you have to have all the assemblies open that are above the assembly that we're dealing with. As long as those SolidWorks will take care of the file management. The second option, just save, copy, and continue. That puts a copy of this thing, puts it on the hard drive, and it just continues on with what you got. So if you wanted to send something to somebody completely separate from what you're working on, you might choose that second option. But in this case, I want to use this first option because I want open files, which is the -100, the -100 file. That file that have references to this original document will now point to the new files. That's what I want. So I'm going to choose that option. and I want to give it a name of, not this crazy name, I want to call it dash 101. And when I do that, it's gonna, this is now called dash 101. And when I close it, once it gets through saving, come on, come on, come on. Okay, so see, it's saved it as the dash 101. When I close this now, we'll go back to that dash 100 and look what's in the tree now. See, it's pointing to the new one I just made. Does that make sense? If not, rewatch the video later, I guess. All right, so now this thing has got a good file structure. All these file names respond, it's obvious what they are. Your student 7, this is the top level assemblies 100. This is a subassembly 101. And then I've got some parts. I got a 121, I got 2 of them, and I got a 123. So your file naming is looking good now. So now let's go ahead, you got a question?
I was just wondering, so like for the like 121 part, is it okay that I did it like that, or do I need to do like each individual?
Yeah, this is not. Yeah, you're right. This is not the way to do it because these are all separate parts. If you make one out of stainless steel, you wouldn't do this. But if you had different materials, now all of a sudden you can't change the material of the individual parts. So it's
because it's like all steel.
What's that?
Welded together. It's like all steel and welded together. Is that okay or no?
Yeah, I would say if they're all the same material. But what about this thing? No,
it's just too much.
How are you going to manufacture that part?
Just weld it on.
Yeah, but how long is it? What's that feature look like? You got some kind of a cutout on the end. This needs to be its own separate part.
Okay.
You see what I'm saying? Because you're going to want to fabricate this thing, and more importantly, your sponsor is going to want to know how to build this thing. And if you just have a big blob that's a whole final assembly, he's going to say, well, how long is this? How do I make this plate? And what if you want to put you're going to want to put a chamfer on this web here. You don't want it to be individual parts.
Okay.
So at some point, maybe not today, but at some point, you need to make a part that looks like this, part like that, make a part like that. That's going to be the same part as over here, so you'll have 2 instances of the same part. And so get Sergio or Nate to do that while you're working on this other stuff. Okay, so and so again, so here's another it's kind of a file management thing. Every time you design a new part, just get into the habit of defining a material. Because if you don't, when you start doing your weights analysis and stress analysis and everything else, you'll have to go back and add a material to every part anyway. So you might as well do it at the beginning. So just right click on the material and say edit material, and then go find the material you've got so that it'll be all set. So if it's 10-10, 1020 steel, whatever it is, apply the material so that the material stays with the part model, and when it goes up the tree all the way to the top level, it'll remember what it's made out of. And you've got all the material properties already built in here.
Yeah, that's cool.
So it is cool. And so if you want to see it in English units, you can just change the units, and there it is, 29 million psi. Tensile strength's about 61,000, yield strength 51,000. And it's all there, it's all built in. So just get used to putting materials on the parts as you make them. Okay, so we're running out of time here, but maybe in 15 minutes we can at least start doing a simulation. So what I did was this morning I pulled up your assembly and deleted a bunch of stuff and ended up with I think it was this thing. So now we'll see how much we can do this last topic, simulation. I think this is the big assembly. That's not what I wanted. File open. I had another one called Summers Assembly. Oh, here's one last thing. All right, so you're going to want to do the same thing. This is not a good file naming convention for your bearing.
No, you're fine. Thank you.
So this part right here is inside of here somewhere. So I want to open this guy up. And there's that bearing. So this is good. You downloaded this from McMaster or somebody. And here it is right here. And so we don't want to give this a name like this. What you want to do is when you download these models, the very first thing you do is open it up and save it as a manufacturer's part number. That way when you do your drawings, all those part numbers and the descriptions all populate in the BOM. There's no manual stuff to do. It all happens automatically. So I want to open this thing up. And this in itself is its own subassembly. And that's okay, but I want to rename this pedestal bearing to the part number. You happen to know the part number, Stephen?
Sorry, no.
All right, so I want to make one up. So I've got the assembly open, and I'm going to do a save as, and that assembly that this thing report to is open. So it's going to now point to this new file name I'm fixing to give it. So I'm going to use this first option, file save as. I'm going to use that first option. And I want to call it, I'm not going to call it McMaster car. I'm just going to give it the part number. So if it's 9342A, say that's the part number. That's the exact name you give it. And this one will save as the part number. And what you're going to do is you're also going to go find the data sheet. Hopefully you've downloaded the data sheet for that part. And where did it go? There it is right there. Hopefully you're going to download the data sheet for that part, PDF file or whatever it is, and you're going to save it in the same folder, and you're going to give it that same file name. That way you'll know, oh, that's the data sheet for that part model. And just do that every time. That way you don't have to keep going back to the McMaster car to find the data sheet. Just put it in the folder one time, and then everybody has access to it. So I want to close this out. Now look at my assembly. There it is right there. It's renamed exactly to the part number, and I have no question. If I want to find out what that is, I just go Google that part number and I'll find exactly what it is. And more importantly, when you do assembly drawings, the bill of materials will automatically populate, and it'll just show up in the bill of materials, and everything will be beautiful. Okay, so all right, so maybe that closes out the file management stuff for now. So I thought I saved this thing. I'm not seeing it. Let's do this. I'm going to close this. So I'm going to get my 100. This is my 100. Now that's yours. File close. I'm going to, this is the 100. Okay, so I want to delete this. Maybe. And so now I got the thing I want to do my stress analysis on. So I'm going to do a file save as here, and I'm not going to do that first option because I don't want to screw up my top level assembly. I'm going to do, I'm going to call this TSU 064. Oh, I'm going to call this maybe dash 201. And so maybe all the 200 numbers are all stress analysis models, or whatever you want to do. Well, there it is right there. I already saved it. So this way, I'm going to have a separate model that I can use to do a stress analysis with. And you can call it -501 or so whatever series you want to use. If it's 200, then you'll know all the 200 series dash numbers are all stress analysis stuff. So okay, so we need to reorient this thing. So we're running out of time. It's 9 minutes to 9. I got another meeting with another class at 9. So hopefully that was helpful. What we need to do next, or what y'all need to do next, is clean up the file management, because if you don't do it now, it's just going to get worse and worse over time. So let's clean that up. Get your files all in the same spot and do that save as trick so you can know that they're all in that one folder. Clean up those errors on the constraints. And then if y'all want to do it this afternoon at 2 or tomorrow, whenever next, sooner the better as far as I'm concerned. I'll show you how to do a stress analysis on this frame right here to start figuring out if this thing's strong enough or we need to change the design. So is that a plan?
Sounds like a plan.
Okay. All right. Well, so we'll close the video now, and we'll follow this up with another video. We didn't quite get to the third, item there, which is SolidWorks simulation. So we'll do that and make that into a second video. So until then, see you next time.